The pipe rack is not part of the drill string, but plays an important supporting role. The rig crew cannot put drill pipe and collars on the ground or a deck. Dirt and debris would ruin them, so they store them on the pipe rack. They also clean and inspect the drill string and other tubulars, or pipe, on the rack. As we discussed in the last section, crew members install the bit on the bottom drill collar. Two kinds of bits are roller cone bits and fixed cutter bits. Fixed cutter bits are also called fixed head bits. Roller cone bits usually have 3 cone-shaped devices with teeth or cutters. As the bit rotates, the cone and cutters rotate to drill ahead. Fixed head bits also have cutters, but manufacturers embed them in the bit's head. The bit's head moves only when the bit rotates. It has no moving parts like the cones on a roller cone bit. Both roller cone bits and fixed head bits come in sizes ranging from only 2 or 3 inches, or about 50 to 75 millimeters in diameter, to more than 36 inches, about a meter in diameter. 2 basic kinds of roller cone bits are available. One has steel teeth, and the other has tungsten carbide inserts. On a steel tooth bit, also called a mill tooth bit, the manufacturer mills or forges the teeth out of the steel that makes up the cone. Steel tooth bits are the least expensive bits. When used properly, they can make hole for many hours. Manufacturers design steel tooth bits to drill soft, medium, and hard formations. With tungsten carbide insert bits, the manufacturer presses very hard tungsten carbide buttons or inserts into holes drilled into the bit's cones. Tungsten carbide is a very hard metal. Tungsten carbide insert bits cost more than steel tooth bits. However, they usually last longer because tungsten carbide is more resistant to wear than steel. In general, tungsten carbide insert bits drill medium to extremely hard formations, but can also drill soft formations. Soft formation bits usually drill best with a moderate amount of weight and high rotary speeds. Hard formation bits, on the other hand, usually drill best with high weight and moderate rotary speeds. 3 types of fixed cutter bits are available: polycrystalline diamond compact, or PDC bits, diamond bits, and core bits. This PDC bit has cutters made from man-made diamond crystals and tungsten carbide. Each diamond and tungsten carbide cutter is called a compact. Manufacturers place the compacts in the head of the bit. As the bit rotates over the rock, the compact shears it. PDC bits are very expensive. However, when used properly, they can drill soft, medium, or hard formations for several hours without failing. A compact's PDC layer is very strong and wear resistant. Manufacturers bond the diamond crystals to the tungsten carbide backing under high pressure and temperature. The tungsten carbide backing gives the compact high impact strength. It also reinforces the wear-resistant properties of the cutters. Manufacturers make diamond bits from industrial diamonds. The diamonds are the bit's cutters. Diamonds are one of the hardest substances. A diamond bit breaks down the rock during drilling by either compressing it, shearing it, or grinding it, as shown in this animation. Here, the diamond is acting like sandpaper, wearing the rock away. They embed the diamonds into the metal matrix that makes up the head of the bit. Diamond bits are expensive. When properly used, however, diamond bits can drill for many, many hours without failing. Crew members run a core bit and barrel when a geologist wants a core sample of the formation being drilled. A core bit is normally a fixed head PDC or diamond bit. It has a hole in the middle. This opening allows the bit to cut the core. Diamonds or PDCs line the opening and sides of the bit. The rig crew fits the core to a core barrel. The core barrel is a special tube, usually about 30 to 90 feet or 9 to 27 meters long. They run the core barrel at the bottom of the drill string. It collects the core cut by the core bit. Cores allow geologists to take a look at an actual sample of the formation rock. From the sample, they can often tell whether the well will be productive. Special equipment in the drill string includes drilling jars, measurement while drilling or MWD tools, and mud motors. The rig crew installs a drilling jar in the drill string if there is a concern of becoming stuck. Drilling jars are usually made up in the upper part of the bottom hole assembly, with drill collars placed above and below the jars. When activated, a drilling jar provides a heavy blow to the stuck portion of the drill string below the jar. Often, the blow delivered by the jar is enough to knock loose the stuck string. To create a jarring blow up with a hydraulic jar, the driller lowers the drill string to cock the jar. Then, the driller applies an upward pull. The upward pull puts the up jar in tension. Eventually, the jar trips when the hydraulic oil bleeds past the ports. The drill string contracts, rapidly accelerating the bottom hole assembly above the jars. When it reaches full stroke, the jar mechanism suddenly stops the motion energy of the string. When the motion suddenly stops, it converts the kinetic energy, or energy in motion, into impact force on the stuck point. This heavy upward blow may free the stuck string below the jar. Measurement while drilling, MWD tools are a big help to the driller as the bit drills. Crew members usually place the tool in a special drill collar close to the bit. MWD tools sense downhole conditions and transmit them to the surface. There, the driller monitors the conditions in real time. Most MWD tools create pulses in the drilling mud. These pulses carry the downhole information up the drill string to the surface. Information collected by an MWD tool includes rock properties, the direction the bit is drilling, torque, and weight on bit. Often, when drilling a directional or horizontal well, a mud motor is made up in the bottom of the drill string, just above the bit, as shown here. Mud pumped down the drill string enters the top of the mud motor. When pressurized drilling fluid is forced between the elastic stator and the eccentric steel rotor, a torque is applied which causes the rotor to rotate. Note that all the drill string does not rotate. Sometimes a well is drilled at an angle. This is called a directional well. The well is steered at an angle specified in the drilling program for many different reasons. For example, they may drill directionally sometimes if the oil or gas reservoir does not lie directly under the rig site. Horizontal wells are drilled for many different reasons. Certain reservoirs can be produced better if a horizontal portion of the well passes through the formation. The transition to the horizontal segment of the well begins at some point in the vertical portion of the well bore, as shown here. This point is termed the kickoff point. The horizontal segment of the well can extend for several thousand feet. Specialized drilling equipment and techniques are required to drill horizontal wells. Select and drag the rig icon to its appropriate location on the chart. These are joints of drill pipe on a pipe rack. When crew members join several pipes together to make a drill string, the pipes A. Put weight on the bit. B. Transfer rotary motion to the bit. C. Conduct drilling mud down the hole. D. Both B and C. Or E. All of the above. What is this? A. Top drive. B. Core barrel. C. Jar. Or D. Kelly. Identify the equipment highlighted. A. Kelly and rotary system. B. Reamer and stabilizer. C. Rotary table. Or D. Top drive. The drill collar on the right is a spiral drill collar. Why does it have a spiral? A. The spiral allows it to drill into the formation. B. The spiral makes it slicker. C. The spiral helps keep it from getting stuck. Or D. None of the above. Tungsten carbide bits have tungsten carbide inserts that are harder than diamond. A. True. Or B. False. Which drill string component is the stabilizer? The common characteristic of almost all drilling rigs is that they A. All drill with Kellys. B. Are capable of being moved or mobilized. C. All drill with top drives. Or D. All can be used on land. This jack-up rig is A. Under tow. B. Jacking up. Or C. Fully positioned in the working mode. True or false? A platform rig can drill many wells from a single offshore platform. A. True. Or B. False. When the lower bottom hole assembly becomes stuck, what tool can be used to free it? A. Stabilizer. B. Reamer. C. Jar. Or D. Crossover. Carry the downhole information up the drill string to the surface. Information collected by an MWD tool includes rock properties, the direction the bit is drilling, torque, and weight on bit. Often, when drilling a directional or horizontal well, a mud motor is made up in the bottom of the drill.